In this video, I am going to find the derivative of a function. We are given that f of x is equal to cosine of x. Now, using the definition of derivative, we need to find f prime of 3x. Now, remember the definition of derivative. F prime of x, if f is a function, f prime of x is equal to limit h approaches 0, h approaches 0, f of x plus h minus f of x divided by h. That's the definition of derivative. Now we are going to use this definition and find f prime of 3x. But before we do so, we need to find what is f of 3x. So if f of x is cosine of x, which is here, then f of 3x is going to be cosine of 3x. Remember, I am replacing x by 3x on the left, so I have to replace x by 3x on the right. Now let me go ahead and find the derivative using this definition. So my f prime of 3x is going to be the derivative. So limit h approaches 0, f of x plus h. So now remember my f of 3x. So this is where people make mistakes. So make sure that you pay closer attention to this. I have to replace this x by x plus h. So it's going to be f of 3 times x plus h. Okay, so that's what it is. A common mistake students make, including myself, sometimes even after seeing it for so many times, I make the same mistake. So instead of writing 3 times x plus h, I'm going to write 3x plus h. It's just a careless mistake, but that could lead to wrong answer. So make sure that you understand what you're doing. Minus f of x. Okay. So in my case, actually f of x is 3x, right? Divided by h. Now that's going to become limit h approaches 0. Now look, is going to be cosine of 3 times x plus h minus cosine of 3x divided by h. Now we are going to simplify it even further. So it's going to be limit h approaches 0, cosine of 3x plus 3h minus cosine of 3x divided by h. Now I am going to simplify this using the cosine formula. Remember, cosine of a plus b is equal to cosine of a times cosine of b minus sine of a times sine of b. I'm going to use this formula to simplify this. Now if I simplify this, I get the following. Now look, here I have cosine of 3x and cosine of 3x common, right? So I'm going to be factoring out cosine of 3x. If I factor out cosine of 3x, what I'm left with is cosine of 3h minus 1, and then this term is this term. Now I'm going to simplify this using this property. Remember, limit x approaches a, f of x plus g of x is equal to limit x approaches a, f of x plus limit x approaches a, g of x. So that formula we are going to use to simplify this. Okay. Now even though this is minus, it applies to minus as well. So sum of the limits is limit of the sums. Okay. So that's what it is. Now if I do that, I get the following. So I break this down into two. So this is the first one and this is the second one, using the property of limit, which is this one. Now look, cosine of 3x, by the way, it has no h in it. So this technically doesn't depend on how h behaves. So you could just take it out of the limit, because this is, you can As far as h is concerned, this guy behaves like a constant. It's not influenced by it. It doesn't depend on h. So we are going to bring it out. In exactly the same way, sine of 3x, it doesn't change as the h changes. So I'm going to bring that one out. If I bring that one out, I get this one and this one. Now we are going to manipulate this limit and this limit slightly so that we can come up with something that conforms with what we are familiar with. If we do so, we get the following. Now let's pay a little closer attention here. What I have done some manipulation of some constants here. I want to make sure that you follow it. So this is just this, so no problem there. Now I had limit h approaches 0. Look, I have changed it to limit 3h approaches 0. Now look, if h goes to 0, 3h also goes to 0. Okay? Because as h gets smaller and smaller and smaller, 3h also gets smaller and smaller and smaller. So both of them approach 0. Now why did I do that? Because I wanted to do something here. Oh, by the way, there is a slight typo here. This should have been 3h. Okay? So cosine of 3h minus 1. So that I could have cosine of 3h minus 1 divided by 3h. Remember the formula that we are familiar with. Limit theta approaches 0, cosine of theta minus 1 divided by theta is actually equal to 0. So I did play around with this thing so that I can come up with an expression that's structurally similar to what we are familiar with, and we can evaluate the limit. Now I multiplied h by 3 in the denominator and I multiplied by 3. So they kind of cancel out. So as if I didn't make any change. In exactly the same way, here I have done the same thing. I have divided by 3, in essence multiplied the h in the denominator by 3 and multiplied it by 3. Now I have limit 3h approaches 0 sine 3h over 3h. Isn't it like limit theta approaches 0 sine of theta over theta? As you know, this value goes to 1, correct? So what happens? So what do we get here? So this is what we get. This limit is going to go to 0. So it's going to be cosine of 3x times 3 times 0 minus sine of 3x times, so let me put a parenthesis around it, 3 times the limit of this thing. But the limit of this thing is 1, right? So what we finally get is this. So this term is going to become 0. So it's going to be negative 3 times 1 is 3 sine of 3x. That's what we are going to get. Okay? So our derivative, finally, what we get is this. F prime of 3x is going to be technically d over dx cosine of 3x is equal to negative 3 sine of 3x. That's what it is. So this is what the final derivative is. And we have used the definition of derivative to find the derivative of f of 3x. Now let me go ahead and summarize what I have done. So just to remind you, all of you by now know what is the definition of derivative. Limit h approaches 0, f of x plus h minus f of x divided by h. So we use that definition, but the critical thing to remember here is this. These are the two things that helped us evaluate the limits. Limit theta approaches 0, cosine of theta minus 1 divided by theta is 0. Limit theta approaches 0, sine of theta over theta is 1. These two properties you have to know in order to be able to come up with the derivative. If we just use the definition and simplify things and use these two properties, we come up with the final derivative, which is this. Okay? So that's what our derivative is. I hope that this discussion was helpful. Thank you very much.